Well, good evening, everybody. My name is Richard Freudenberger. I'm the Energy and Resource Coordinator here at Living Web Farms. We are a nonprofit research and educational facility. Here we have a school, and we also have the greenhouses and a small garden here. There's a lot of soil and crop research done and growing done here. We have another farm at a location in Grandview, which is Grandview Lane in Mills River, just about 3 miles from here. That's our biochar facility and also our livestock farm. And then we have an additional acreage on North Mills River Road, and we are working there to grow and build the soil, and it is going to be growing bigger as we go forward. What I'm going to talk about is mainly and almost exclusively the building and designing and modification, if you have questions about that, of a small-scale germination chamber. So I'm the tech guy, so we're going to talk about lighting, humidity, we're going to talk about heating, we're going to talk about controls, we're going to talk about the actual structure of the little chamber that it's in and why I chose the materials I did. Just last year, before the propagation season, I tested the equipment and tried some different things, and it's still in transition. And we built a new chamber using the same dimensions and made a few modifications, selected the parts and the controls to keep it at a fairly reasonable expense. The cost of a commercial germination chamber is somewhere between about $2,200 to over $3,000, granted for a little bit of a larger chamber, but this particular one here measures 22 inches in depth by 80 inches in length, and it's 36 inches tall. I'm going to talk a little bit about why we even want a germination chamber. And really it's for consistency and control. You're able to start all the seedlings at one point in time, and they all come up together in a consistent way so they can all go out into the beds at the appropriate time. And they're all going to be about the same. If you put them on tables in a greenhouse, or you put them in the kitchen or whatever, however people might do that, you may not have enough room, or you may just not have the same control situation. So you'll have fits and starts. You'll have maybe one group coming up too fast and the next one isn't catching up. It just gets to be a problem when the transition is made from the actual propagation into the soil. And it also is a controlled environment, so we can fairly well control the humidity and we control the temperature. The other thing is we have lighting in there. I've seen some home-built designs that are made out of refrigerators or tall, narrow cabinets. And you can stack quite a number of trays in a design like that, but if you're going to use a light, you can only reach the top tray. So we've actually turned it on its side, and the lighting can achieve much more tray capacity. The trays are 21 by whatever they are, 10 and a half or something. And so we have 7 of those to fit in there. I try not to be brand specific. I mean, it doesn't really matter, but in identifying some of the parts, I have mentioned brand names because it's just easier to locate them. It's so easy just to Google the descriptions I've given in the handouts, and it'll just come right up. It doesn't really matter where you get them. Many of the greenhouse suppliers or the Amazon suppliers carry the same equipment, just different sources. These make it easier. They're sort of like plug and play. The one I have used out there is a little more hands-on. We'll have to, wire it up and build a box and get the circuits straight. But instructions are reasonable, and when they're not reasonable, it's easy to go online and just search for comments or input from other users, and it's not that difficult to find the information you need. If we have any questions on germination itself, it might be helpful to have Patrick Battle, our director, maybe answer a few of those questions if you have those questions.
I want to make a comment too. 7 across, but you can actually go at least 3 up, right?
You can, yeah,
21 flats.
Yeah, the top place is to put those 7, but you can fit actually 21 trays because really in most cases, and you can correct me if I'm wrong, in most cases what you're after is the heat and the humidity. The lighting is
lighting we put in there for grafting, for curing grafted tomatoes. The germination chamber doesn't have light. It's just for germination. But we turned it into a multiple germination chamber, tomato curing chamber, and then they want that humidity. And what I kept having happen was when I was taking the tomatoes out, they were like starting to take, but the motion of taking them out to put them in light meant that I would lose a certain percentage. So if I can leave them in there and just turn the lights on, then I upped the percentage like 30% in takes because I didn't have to move them at that critical time. So that's why we have lights. About the only thing that I think there might be any reason to have light otherwise would be if you were germinating lettuce in the summer. If it's hot out, then light helps lettuce to germinate. So if you just didn't cover the lettuce seed and put it in there and had the lights on, you might get better germination. But I don't even know. I think you'd be better off putting lettuce in a basement that time of year than in a germination chamber that was in a greenhouse like we have it. I don't know if there are any other questions or not, but just so you know, there is more capacity unless you're doing, if you're curing the tomatoes, then you probably are going to take up the germination chamber just for that. You know, yeah.
What about if they get leggy?
If you're doing a germination chamber, the minute they germinate, they come out of there. You've got to watch it every day. And indeed, the guy who taught me this, Wade at Troy's greenhouse, he stopped putting his cabbages and other brassicas in there because he'd get distracted, and it'd be 2 days later, and they'd be leggy.
Okay.
You know, so this is a check it every day. The minute you see, I'd say 10-15% germination, take it out because you know the rest are right behind that, and we don't want to then get distracted and have it sit in there for 2 days because they will get leggy. You know, now if you're only doing 7 and you weren't trying to cure grafted tomatoes or something, you could turn the lights on and that'd solve the problem. Certain things like onions want no light to germinate, but you just usually solve that by putting enough soil on top of them.
Curing tomatoes, is that part of the grafting?
Yeah, well, I don't know if cure is even the right word, but it's you graft them and then they want to be in a high humidity situation, right? With very still air, like no wind or anything, for about 10 days or something. And it used to be, for the first day or two, they're not photosynthesizing, they're in shock. But then after that, they want to get light. So I would have to take them out of this one place and try and create some other kind of high humidity, which wasn't easy to do anyways, but I managed to do. The problem was that in moving them out, they were barely taken, and I would lose some every time I moved them. Now I don't have to move them. I just leave them in there until they're actually really set. You know, they've actually totally healed over. And then I take them out because I have the light, and that solves the problem. So curing, that's the word I made up. I don't even know what the term for it is, you know, but keeping them in there in the high humidity until the graft is taken.
One other thing about light, especially if you're building it yourself, an inside light with the intensity that we have in there makes it really nice to any kind of adjustment, or you want to tighten a screw, or you want to adjust the float in the bath, or you want to adjust the shelf levels. You know, once you get that light on, it's really a lot easier to see inside there. This chamber will work in any other location as well, so it's nice to have that light in there. There's actually 2 fixtures, and they're staggered, so the light is spread all over the whole thing. What I want to start with is just talk a little bit about materials. Building materials, the first thing you really have to do is decide how much you want to spend and what you want to make the chamber or the box out of. The unit sits in a water bath on legs. So a water bath is a tray, a galvanized metal tray. The original tray we used, Pat got from a greenhouse guy in Burnsville or something. Yeah, in Burnsville. It was fine. It was a heavy gauge galvanized sheet metal. It's a 6-inch tall, 79 inches in length and 20 inches in depth. And the sheet metal guy will bend you that up. We paid $74 plus tax, which I was very surprised at. I looked online for alternatives, maybe for some heating and air conditioning suppliers that would ship them from Ohio or some other place where they did volume wholesale manufacturing of trays of different sizes and widths and everything, and gauges of metal. The gauge is the thickness of the galvanized sheet metal. Obviously, the heavier it is, the more stout, but the price goes up too. So I was trying to get a reasonable cost. Most of those were running about $160 and up, and then we had to pay to ship something the size of that bookcase. That was a little ridiculous. So ended up going to the local sheet metal guy in Swannanoa, and they make up these things for drain pans for HVAC systems, air conditioners and stuff. And they'll make any size you need. So he just looked at it. I drew up a drawing for him and told him how I wanted the seams and everything. And fairly simple. There's the corners are seamed. Normally the short ends would be seamed. He seamed the long ends, which can be a little problematic. Opens the door for a little more leakage because any stress occurs on the long seam. It's better if that long seam is folded and then the short seam is seamed. In the old days, I guess, they would go through and solder all around the inside of the seam to make sure it's totally leak-free and it's a solid. It's almost like a weld. It's a silver. Actually, it was lead in those days, but now they'd use a silver solder. It's expensive. So now we use JB Weld. It's a 2-tube special epoxy that has metal filings in it, a very strong epoxy that is also temperature resistant. I think it goes down to well below freezing, and it goes up to 400 or something degrees, if not more. It's easy to work. It sticks to almost anything. They actually use it to repair automotive parts, engine block cracks, stuff like that, so it's fairly durable. Not all that expensive, so we could have either used that, which I found tedious because you have to mix up. They only have little 2.5-ounce tubes, so you'd have to mix up, do like 2 feet and then mix another bunch up and do 2 more feet. So it just seemed a little bit tedious. So there's a product called Lexcel, a roofing and air conditioning sealant exposed to high outside temperatures, direct sunlight, that kind of thing, rain, ice, all that. At Home Depot or whatever, you'll see the row of 10 different products by the same company. Number 212 is the one that I use there, and the one that I would say would be a good choice. All you have to do is get a little caulking gun and just go through and just do the seam all around the edges and up the corners. So that tray, I just basically duplicated the existing tray that we started with because we knew it worked with the trays, with the seedling trays we had. If I was to do it over again, it probably would have gone to a 24-inch one because that way there's a little more leeway in the just in putting the trays in and out. There is more energy involved. Of course, that was one of the reasons I kept it smaller. But a larger tray or tub or pan, I guess we call it, the water bath, 22 inches or even 24 inches would be perfectly okay. The length, again, is about the same, 80 inches, 79 inches, something like that. You have a certain base, and then it comes up 6 inches. Then there's a flange that comes out 2 inches all around it to stiffen it, and then they fold the edges under to keep it from sharp edges from cutting your hand or body when you walk by. They do a fold over. The sizes are fairly flexible. You can just tell them what you want. They will ask for a drawing. It's not you don't need to go to an architect and have them do the shop drawing. It's just you can just sketch it out for them. But 6 inches high, 79 inches long, and 20 inches deep. The tray is like this, and the legs sit in the water. This is filled with water, and there's a heating element at one end. The legs sit in water, 6 inches deep, and they extend out. So it'll extend out about 30 inches up. So we need something to stay in the water and without rotting. Ideally, if everybody had a TIG machine in their shop or whatever, I'd probably use angle iron, aluminum angle iron, and weld a basic frame of maybe 2-inch angle iron, and that would be a sturdy, 4 legs and some cross members that would be right over the top of the pan, right over the edge of the lip, and that would be solid enough to just keep that whole thing. There's not a lot of weight with the plants. I mean, they're not all that heavy. But we don't want the chamber to rack. In other words, racking is, swaying, and then it'll throw the doors off, and they won't seal right and all that. We need a good seal around the doors, and so the humidity and the heat doesn't escape. So what I've chosen is composite lumber or decking. It's called Trex. Mainly it's used for deck surfaces. They make a rounded edge kind, and then they make a 1x6 with a grooved edge, like a tongue and groove, except there's no tongue on the other side. It's just 2 grooves. And then they have little clips that fit in between, and they pull the wood down or the plastic down. That will work. The plastic is a recycled plastic. It gets compressed and binded or bound. It doesn't rot. It doesn't come apart. You can drill it. You can cut it. You can. I don't think it takes paint very well, but we don't need to worry about that. So what I've done is got just enough of that to deal with the corners of the chamber. The bottom of those 4 posts are going to go in the water, so that was the whole purpose. And then there's a framework around the back and the sides and the front to hold down low, just a little bit above this 6-inch line where the top of the pan is. And that is 1x6s, which is actually 3/4 by 5.5. And that goes around, that band goes around the bottom. I put in stainless steel bolts and short pieces of angle iron to gusset or strengthen the corners. So basically I have 2 pieces of material into a form of a corner, and then put angle iron in there and bolted it, and doesn't rack. I mean, it will if you lean into it, but it's fairly tight. And the stainless steel in those areas, it can get expensive. The hardware is a little more expensive, but where it really counts on those structural members, I did that in and around the humidity areas. That's a good idea to think about that. It doesn't really need, I think I used a 3/16 inch bolt and a 1/4 inch bolt in other situations. There is some wood there too, some plywood, and I've used some white pine in there as well, but not the stuff that actually touches the water. I really wanted a flat face for the door to shut up against. Now the Trex is heavy, it's dense, and if you take a piece of lumber and you look down when you buy it, you don't want one that's warped. So a lot of people, you'll notice them in the store, they'll sight it, make sure it's reasonably straight. And this stuff is very straight on its edge. I mean, if you turn it on its edge, it doesn't bend. But if you lay it flat, it just waves. And to take a piece 80 inches long and use that as a frame member that you expect a door to close against and make a seal is a very high expectation. It's not going to work. On the deck, of course, where it's intended to be, where really gets put, they lay them down on rafters at 12-inch centers, and they get held down, all along there, so it doesn't warp or anything. It's down solid. But for our purposes, it can be a problem. So I keep it at 3 feet, or even maybe 4 feet. It's not. They don't really do that much. But when you get a long piece, it will bow a little bit. What I did was I took the 6-inch lumber and just sawed it lengthwise down the middle, just to save materials, really, because it doesn't need a big broad corner. It's just enough to hold it. So I was able to take one 36-inch piece, and that's one leg. By cutting it right down the middle and making my angle and bolting it together, that's one leg. Another 36-inch, 2, 3, 4. So you don't have to use too much wood, or plastic in this case. It's approaching about $30 for a piece that's 12 feet long and 6 inches wide, which is really sort of expensive. I got it at a discount. I went to a salvage construction house and got it at, I think it was $21 for that. It's still, expensive when you can get that same piece in wood for, considerably less. So you have to balance, for the purpose of having it in the water, it was worth it to just get the 12-foot piece. I think it's one 12-foot section and then another one to make to finish everything I wanted in plastic. The other stuff was just white pine. There was some spruce too. But that I treat with a mixture of linseed oil, boiled linseed oil, half of that and half turpentine. Painted on there or rubbed in there will soak right into the wood, and it really does a good job of protecting against humidity. It was never meant to protect against being submerged in water and staying there for 4 years, but it will protect against exposure outside and in this case inside the chamber. Avoiding using things like Thompson's water seal or any really toxic chemical that will outgas, get into the humidity of the chamber, and then affect the plants. And that's why we're not using treated lumber. Pressure-treated lumber is just out because the risks of the salt and the toxins in that treatment process is going to get into the water and into the mist, even though it's not really a hot mist. It's not steam really, but it's still a mist, and it's eventually going to get into the soil of the trays. So we don't want that. The important thing about linseed oil is when you use it, as I said, it's a 50-50 mix, turpentine and linseed oil. The linseed oil is actually has a ability to spontaneously combust. If you had a project and you put a bunch of rags and soaked them in there and rubbed your wood and dumped them in a metal container, say, and just piled them there for your scrap rag, they can heat up so much just on their own nature is to heat up, and it's possible, and it has happened, that they can just burst into flame, and you wouldn't even know it. I mean, unless you were standing right there, it can happen. It could be a 12-hour event. And the turpentine, of course, is flammable too. The linseed oil is not benign. I mean, it is mildly toxic, but it is not. That's if you drink it. I mean, that's for us. When it's used like this, it doesn't really get out. It gets into the wood and stays in there, and it just seals everything, and it actually gets deep into the the grain of the wood. So it's not a surface application like the water seal would be, or paint. It's actually, gets them pretty deep in. But I do want to make it real clear to you that if you do use the linseed oil the only way to really prevent it is just have a 5-gallon bucket full of water. When you're finished with one rag, you just throw it in the water. And then whatever else just goes in the water, and then it just can't do anything. And you can dispose of that properly, when you're finished. Another option is for the wood in there is cedar or redwood. Redwood is very difficult to find anymore, or at least cheaply. But cedar or a locust would be okay. Osage, we don't have it here, but cypress wood, I've seen that. I mean, it's more of a deep south wood, but I would say that cedar or a locust, black locust would be a good, what they make fence posts out of, if you can find it. Because we're not talking about pieces, they don't necessarily have to be 8 feet or 10 feet long. I mean, if you can get sections that are 36 minimum, so it would be 36 to 40 inches, like a fence post, and you cut that up, that would be fine if you're going to cut your wood from the tree. If not, you could still find flat, 1x6 sized or 1x3 sized purchasable locust around. So that's basically the framing part. There's probably other ways you could do it. Like I said, with aluminum angle iron, you could use angle iron, but you'd have to probably take it out every once in a while and recoat take the rust off it and repaint or recover everything so it wouldn't just ooze out rust. So I would avoid that. I mean, I think the composite wood, plastic wood, is probably going to work out pretty well as far as things go. I've looked at samples that were left out in the rain for 4 years, actually sitting in a tub of water that hadn't split, hadn't swelled or anything like that. The glue hadn't come out of it, so it's pretty. I think it's pretty durable. The other part is, the other important part is the insulation. So what are we going to use for insulation? It has to be humidity, able to take humidity, high humidity, and it has to be easy to work with. So it's going to have to be a sheet, some kind of sheet insulation. But I have found that the extruded polystyrene, the 4x8 sheets of Dow or Lowe's or Owens, Corning or whatever, you'll see it in the stores. That's probably the best choice. It has a very high R value per inch. It's a 5 R5 for every inch. I used 1 inch material in this one. It is not expanded polystyrene. There's 2 types of blue, and they're both blue. Well, some brands are pink, but just think in terms of blue. You can pick it up and feel the difference. The expanded polystyrene is lighter. It's a little more flexible. It has its purposes, but it's not meant to be in a high humidity or buried subsurface below grade situation. So what you're looking for is XPS, extruded polystyrene. I know expanded also sounds like EX is the same thing, but they actually label the extruded stuff as XPS. It'll be stamped right on there. That is a denser, stiffer, more durable, and completely waterproof material. And it's easy to cut. It has a very high modulus of pressure, so that they use it underneath slabs. That's the stuff they use underneath slabs when they pour even thick slabs to keep the soil separated from the cement, so you don't have a migration of heat from your building out into the soil. So all that weight of concrete, I mean, it's just, it doesn't crush it. Whereas the extruded polystyrene is so foamy that it would just flatten it and it would make an uneven thing. Yeah. Expanded. Yeah. Or expanded, I'm sorry. Yeah, expanded is not what you want. Extruded, XPS, is what you want. The other thing, it's on there, and what I tried to do was reuse some of the materials we had used in the prior version of this. So there already was a section of polyisocyanurate, which is a lightweight, creamy colored core on both sides. There's a foil facing. That's about the only thing that really makes it water resistant. It doesn't soak up moisture, but it is not nearly as resistant to moisture as extruded polystyrene. So you got a couple sheets of that, and cut that, and I will show you when we get down in there. Cut that to fit basically between the legs, the four corners. So you've got a little space in between the ends of about, in my case, it was probably about 18 inches or so. So we just cut a piece and jammed it in there. Both ends. On the back side, it's just a complete sheet cut to fit. It gets bolted with deck screws and some big fender washers. It gets bolted all into the back, because the back side you're really not going to be bumping into. If you were going to be bumping into it or pushing up against it a lot, I would suggest facing that, covering that with something more durable. Could be plywood, or it could just be something like there's actually a fiberglass reinforced plastic sheet that's 4x8 that they have at the home supply stores. That's usually used in bathrooms and things like that, but it's a pretty durable, it's a very thin, 30 thousandths of an inch, maybe a little bigger. There's two different sizes, two different thicknesses. But anyway, it's very thin, and it's 4x8, and it's actually pretty tough. I mean, it's wobbly, it's flexible, but it's actually pretty tough. So you could face any exposed insulation with that stuff, and it would be inexpensive, and it wouldn't hurt anything. The door in the front is a sheet of plywood that's cut to the size and then lined on the inside with polystyrene board, and that's screwed in. So that just folds up. I did not do a door like this because being 80 inches wide, those doors are 40 inches. That's a lot of it's a lot of asking pressure on the hinges, plus people can't walk by you. Those doors are open, you're sort of in the way. So what I did was I just dropped it. It's a drop-down front door. There's many ways you could do the door. I mean, you could just do it with a 40-inch, two 40-inch doors, or you could do a bifold. So you cut the 40 inches in half and then put a hinge on that too. So like some closets are like that. They just fold back and then the whole thing opens up, and that keeps it short. You could do a sliding door that lifts up. You could do a top one, the hinge at the top, and then somehow pokes back. But since we had equipment at the top, I didn't want to do that. You could have one that actually comes off and not even have any plywood on it. You could just use the stiff 1-inch board itself. You could actually put handles on it and just pull it off and put it on pins. I mean, it'd just be awkward, but it saves some money that way. So it really just has to seal that box completely. At the bottom there's a water pan, and the sides and the front and back is an insulated wall that has some structural ability in the corners, and that's basically it. The top is just a sheet of cut-to-fit insulation, and on top of that I put a plywood surface because we have stuff up there. You have to put something durable up there because it will get punctured if you don't have something solid up there. We do not need 3/4 inch. I've even said in the materials list 5/8 because that's really all you need. You could even go down to 1/2 inch, which is considerably cheaper, but on the front door, if you're doing it the way we did it, a 1/2 inch door will tend to be on plywood would tend to be a little warpy, and it may not seal right. You could fix that by framing just the edges out with a 1x2 and screwing it tight, and that'll stiffen everything right back up again, and that's another way of doing it. But that's why I don't want to say the way we did it is the only way, because there's a lot of different ways to do it. As far as hinges and stuff, just galvanized, regular old barn, small strap-type hinges on most everything. I don't think there's any other hinge that's not a strap hinge down there. They're inexpensive, they're strong, they're easy to get. As far as the screws and stuff, the inside are pretty much stuck with stainless steel, but being careful about it is not to spend too much money on every single thing being stainless steel, but just the important structural stuff. And for the rest of the screws, pretty much all deck screws, the kind you use in exterior decking and construction, where you have a very strong screw in standard, mainly, I guess they're 1.5 inches all the way up to 4.5, and they're either number 8, number 10, number 12. So it's a fairly substantial screw. And the most important part is they're covered or coated, totally rust-proof. They're made to be out in the weather for years and years without rusting apart. You take a regular zinc screw and use it in the deck, it'll disintegrate to the point where it'll just if the wood has any tendency to warp, it'll just spring up and break the rusted screw. By the time it's gotten down to a skinny little thin string of rust. So we don't use those screws. We use decking screws, which they're probably about twice the price of a regular screw, but you really need to use them. So the lighting, it's a chamber, of course, and we have a lot of humidity in there. So we're running humidity levels of 95% in there. So we have to go find what they call not waterproof, but they're weatherproof fixtures or high humidity. There's specific fixtures that are made for that. And normally in industrial applications, which is where most of them are made to go, they can be pretty expensive. They're I think the cheapest one I found was $160 per fixture, and they were up to over $400 for guaranteed, in hospital situations, in industrial situations, whatever. But then right at Home Depot, I found a $67 fixture, which was the same thing. I mean, I don't know why. I guess it's made for wet locations, is what they say, but it's fine for this. It's made for outdoor, like carports or garages or shops that are maybe not shops, but places that are high humidity, greenhouses, whatever. So that's what I got, and you'll find them in there, $67, $68. And in the materials list, I've pretty much listed everything, where you get it, or at least what it is, so you can locate it. There's two of those, and they're shrouded. Of course, they have a acrylic cover. They're not exposed bulbs. They have an acrylic cover that is sealed around the edge, so it keeps the thing watertight. And the bulbs then are T8s. It's a more modern bulb. It's thinner, more energy efficient. They're 32-watt bulbs. They are also balanced to provide a much broader lighting spectrum than you'd get from just a single cool white bulb or a single warm white bulb. One bulb is the low end of the spectrum, and the other bulb is the high end of the spectrum. So that's measured in Kelvin. It's called K, and you'll see it if you look on the bulb, you actually see that. That's the color balance. Like if you look at these lights, see the difference between that one right there and that one there? There's two different, they're two different, that's a LED and that's a compact fluorescent. But even if they were both LEDs, the yellower light is more of a low end of the numbers. They'll go from like 2,500 up to 6,000 K, and the 2,500 ones are warmer and softer and yellower, and the other end of the spectrum is a brighter, harsher, one like that there. Those two are the only ones like that. So what we're trying to do is just get instead of focusing in that narrow mid-range, we're just trying to balance everything by getting one high and one low, and they both combine and spread that more broad spectrum light over the whole thing. We have two of them, 4 bulbs altogether, 2 fixtures. So the way I've set it up is staggered them within they're 4-foot fixtures, so we staggered them within there so that everything gets light. It's set on the 24-hour timer, so it'll repeat its cycle every 24 hours. You can have it come on for an hour, 2 hours, 12 hours, whatever you want, or just 15 minutes. So it's a pretty good intermatic timer, like you can get it. I've seen them in the Ace Hardware and whatever, and I think I've listed that in there too. The water bath has a heating element in it, just like a hot water heater. But in our case, it's 110 volt. It's not the 220 volt water heater element that you'd find in the regular residential tank. The only reason they use that high voltage and that high wattage, they're 5,000 watt in the water tank. They're 5,000, not our water tank, but in the hot water tank. They are 5,000 watt, 220 volt elements, and there's 2 of them. There's one high and one low. The only reason you need that much power is for what they call recovery. So when somebody drains the hot water tank, the next person isn't waiting for 4 hours before it heats up. It'll come back up fairly quickly because all that power is going into it. But you don't need to do that. Our water bath, it stays pretty consistent all the time. So once it's heated, it's stays there unless we unplug it or turn it off. So we can go to a regular 110 volt element. Sometimes they're used in mobile home water heaters and some smaller campers and stuff like that. And so we use that, and we don't really have to worry about the drawing too much power. We don't have to worry about a 220 volt circuit to find a dryer plug to plug it into. So we just have a regular plug, and that's a 15 amp circuit, just like a space heater would be, a little plug-in space heater. They're 15 amp circuits. So that's the one we used. And the other thing to be aware of, and I think I mentioned that in the handout, is that if the pan doesn't have an autofill, we have a float in there that fills it up because it'll evaporate. As it heats up, it'll also make humidity as well, and it'll if you didn't fill it occasionally, it would drain down. Once the element is exposed to air, it'll burn out very quickly. Because it's supposed to be in the water, so once you've exposed to air, it'll burn out. They make what they call a low watt density or ultra low watt density element, and they will not, it's not that they won't do it, but it takes a lot longer for them to burn out when they're exposed to the air. So that's something to think about. They're not that much more expensive. So if you're not self-feeding, auto-feeding your water pan, then you might want to look into that. And the other thing that I had an email from a gentleman who couldn't be here, but he was asking questions. The other thing is you can actually use a 220 volt element and hook it up to 110, but it'll only, you would think it would give half power, but it doesn't give half power, it gives a quarter power, because that's the way the formula works. You're feeding 120 or 220 volt circuit with 110 volts. It's going to drop your 5,000 watts down to, 1/4 of that, 1,250 watts, which is really just about what we use. The element I'm using in there is 1,500 watts. So you can do that, and it's easier to find an inexpensive ultra low watt density element at 220 than it is to find it at 110. You can still find reasonably priced elements that are 110 volt and low watt density. Don't let your element get exposed to the air if you can help it. And that's, that even goes for your hot water heater. If you ever had to drain your hot water tank for whatever reason, before you do it, flip the switch to shut the power off to it, because if you leave the power on, it's going to burn it, or if you forget, and before you have a chance to fill the tank back up again, if the power's on, it's going to burn it. So, just keep the power off till the tank's completely full, and then put the switch on. We also have a humidifier that it's actually an ultrasonic humidifier that's basically just a household room humidifier with a 2-gallon reservoir on it. Not all of them have that large of a reservoir, so it's worthwhile looking for this particular one that I found is the Turpentine. I got it on Amazon. I've seen them in stores. I think they were in Kmart, but we don't have a Kmart here anymore. But anyway, you can order them online. They're about $40, I think it was $49 or $54 or something like that. But that has worked very well for us. So that has to be controlled, though. You don't just leave it on all the time. You want to be able to turn it on and off as the humidity. To sort of balance what doesn't come from the pan, it may have to be supplemented with the ultrasonic mist. Now, before we used the ultrasonic style, we used the old-fashioned heating, the kind that you would put water in, maybe a little salt, and then it would make a vapor, and that was a hot vapor mist. But that is a little more problematic because it does have a salt residue. You have to put salt in it. It's a hot mist, all those things. So the Turpentine ultrasonic is a vibrating mechanism that just breaks the droplets into little teeny microscopic mist, and it's a cool thing. The other thing about the hot thing is you could burn yourself. I mean, I have put my hand on the nozzle, and it comes out, and it's hot. So this is just a cool mist, and it works works very nicely. But that has to be controlled. So what we do. This is a plug-and-play version. It makes it a lot easier because it's already been pre-wired. That's the one I've actually used down there, and I had to wire it up myself. That's just the part of it. So, there's a difference. So basically, with this unit, which they use for all sorts of things, beer making again, charcuterie, where you have humidity control, anything you really need humidity control, like I think some reptile people maybe use it. There's just a lot of different uses. So you plug the device into the wall, that's this one, and then you plug the machine, which is a humidifier, or it could be, any number of things, but they're really made for humidifiers, into that thing. So this controls power comes in here, and this control unit tells that plug when to go on and off. And how it does that is this is the sensor, humidity control sensor, which has a fuzzy, furry. Some of them have synthetic fur, and some of them have. I think it's some kind of a animal fur in there that just works to absorb the moisture, and you can't dunk it in the water, but it reads the moisture levels, and then it sends an electric signal back to this thing, and it's fairly accurate. I mean, it really is. This one's 1 to 99% relative humidity. So that's the plug-and-play version. I don't remember. I think it's about $29 for that one, and that's you turn it on, then you set your level you want when you want it off, and then there's a built-in hysteresis, which means you don't want it to cycle on and off constantly, just when it's traveling between its, to shut off, and then as soon as it drops just a little bit of humidity to start back up again, because that'll ruin it's just too much pressure on the humidifier. So there's a little space between when you tell it to shut off, and then it waits, and then it gets told to turn back on again after a while, so it's not cycling back and forth. But this one, the Wilhi, I think it's called the Image in the handout, but it's I don't know why or how they do it, how they set up their structure, but I've seen the same piece of equipment under many different names, but it's the same one. I mean, I can see it says Wilhi. I can see it's the bottom of it. They're all the same. So it's a Wilhi Image, and this one's the 8040, which I have listed in there. This has the same humidity sensor and the temperature sensor, and relative humidity depends on temperature as well as just basic humidity. So it has to gauge your temperature, and then it adjusts and gives you the relative humidity from this one. There's several leads back here, the 4 from the sensors, and they tell you right where to plug in there. That's no big deal. And then there's the power in, and it tells you where to do that. And then there's the power out, and you plug it in, and it will activate the machine, and then after it senses your situation, it'll turn on or not turn on the humidifier. Push the button to turn it on, and then you go through the menu, and it'll say Fahrenheit, centigrade, settings for humidity, what your range is, high end, low end, and the hysteresis, meaning how broad you want that range to be. So it's all, they have a fairly detailed instruction manual, so you can set all that stuff. But really, what you really want is, the most important thing is when the machine starts and when you want it to shut off.
Does it have anything to do with like turning a heater on and off?
No, that's a totally separate system. That is a $24.95 piece of equipment. Common ones that you find that govern humidifiers in buildings like this, that's probably going to be about $150. So, you can see why people are migrating to that thing. It takes, I think it has a 10 amp limit on it, so you can operate something up to 10 amps from that little thing. I think ours is much lower than that. So ours is probably 2.9 or 3.4 or something like that. So it's very small. Once you get above 10 amps, you have to use a relay. A relay is an automatic switch that takes a lower current and then switches so it has the ability to turn on a much higher current without shorting out that thing. The terminals aren't that strong. I mean, so you don't want to hook the terminal up and then drag the thing around by the wire or pull it. It will break. This one you can't because it's already been sealed and made. The water bath is controlled with a conventional Dayton, although there's many other manufacturers, but ours happens to be a Dayton. 0 to 130 degree thermostat, what they call it, remote bulb thermostat. So you put the thermostat on the wall, and there's a wire, and then a little bulb hangs into the chamber, and you set that thing at whatever temperature you want. It's 95 degree water you want, and that'll control the heating element until that water gets up to 95. Then it shuts off.
What's the name of the fab shop?
Gentry Heating and Air. They're the people that do almost all of it, from what I've heard. I mean, the guys that, some of the other people I work with in the biochar crew and people who do things like this more regularly, they go to Gentry. There's a few sheet metal guys around in Hendersonville too, but they're a lot of those people are phasing out their sheet shops. They're for whatever reason, I don't know.
Humidity setting that you put it on.
We varied. 95 was
basically 95 to 85, depending on. I think tomatoes you want a little lower so that you don't get a lot of water build up on the leaves and make the leaves get heavy and knock the graft off. So I think that was 85. But it could be 95 for the germination. Water temperature is only determined by, the way we do it, by the need for that 72 degree air temperature. So the water temperature actually is probably considerably warmer for short bursts of time, but the overall temperature of the chamber is going to be 72. But it never seemed that it got too hot to inhibit lettuce or something like that. Lettuce and all pop fine, But it wouldn't be, it's not on for very long. I mean, it doesn't take long to make a steamy shower experience and get that temperature up in that small space, And
then you've got to realize that it's insulated, so it doesn't, like once it's up to temperature, it doesn't lose it in 5 minutes. I mean, it's, it's there. So it's, and also we're in a greenhouse. I mean, if you had it out in the back porch under cover and it was 30 degrees outside, it'd be a whole different story.
But you don't want to over-insulate either, because you do want that thing to come on once in a while, because it's making the humidity.
Right.
Some insulation is energy efficient, but if you overdid it, it would never come on, you wouldn't get humidity.
Well, the humidity is also supplemented by the humidifier, but you don't want to rely 100% on the humidifier, because it's asking a lot for that little humidifier to fill that whole chamber and keep it filled. So basically what that's doing is filling in the gaps that the other one doesn't.